How's it going, everyone? Welcome to another video on the front-end system design, a course taught by Yifni Ray, a software engineer that has previously worked at JetBrains over 3 years, and then now he's currently at Meta, right? So he made this particular course as a way to those who wants to dedicate their time and energy to be UI or front-end developers, UI specialists, right? We need to know is the fundamentals of system design, because at the end of the day, we're going to build systems, right? Uh, Not only build system, but also find ways of how can we actually is make those systems maintainable. That's the two things that we are going to offer, at least for the next 3 to 5 years. Okay, and at least for the front end system design, it can be a little bit more. Okay, it can be, well, you're going to provide now this over because this is the fundamental, it won't change, so it can persist at least for the next 5 years, roughly speaking. But when it comes to maintenance, a lot of the time those kind of applications, you need to require is more like techniques and systems as a way to provide that. Those systems that will evolve over time is something that, again, it go beyond the scope of this course, but it's important to recognize that. So not only we're going to design systems, but also we need to find a way to maintain those systems, right? And therefore make it adaptable to the change. So that's quite interesting. That's a very revealing thing, especially as a UI specialist. For backend developer, the story is quite similar, because at the end of the day, well, you actually need to do that kind of thing. Quite similar. So, because of that, well, yeah, because of that, we need to find a way as to how can we keep track of all of that? How can we keep up the pace of all of this? So that was a very interesting overview of what we have learned so far, especially or the reason of why this front-end design systems, and when you compare and when you combine that with the maintenance, so building and maintenance, those things are important for a goal. The goal of this is to now build web scalable applications. So anytime you have a system and a maintenance, you also need to apply that to your own life. So if you have a system, for example, to keep you fit, all right, then you need a maintenance to do that. A set of systems and practice and process involved to actually reach or maintain that goal. In this case, if you wanna look fit, not to mention if you wanna eat sleep, or eat well and sleep well, or eat well. Yeah, those are the kind of things that you might want to have. So, but in any case, because in today's video, we're gonna focus this on the DOM API. Following is the best practice, as well as to a more practical aspect of all of that, which is how you can now, by understanding is the core fundamentals, how you can, when you need to actually is building low level libraries like state management or virtualization, among other things, or when you need to, for example, create some kind of components, let's say a charge engine or yeah, like a charge engine, or when you need to actually create a lightweight application, okay, um, with minimal web app footprint. A lot of the time it's important to understand is how this is the fundamental, how these fundamentals work, and then how frameworks actually use those fundamentals as a way to allow you to do more complex stuff. For example, building more complex web API. And today we're gonna focus about that on the DOM API. So what is the DOM API? What is so to recap, what is the DOM API? What we're gonna do with the DOM API? The class hierarchy of that. Understand that the DOM actually is not the DOM is language agnostic. So any other language like Python can actually make use of this, okay, and parse and then translate that or act upon that, manage that. We're also going to look at what are the most common operations that we can do, like querying data or access to data, as well as the couple methods for that. Also, the add and remove elements. What are the trade-off of that? And well, a more practical approach to that. So yeah, let's get into this. Let's get into this. I'm right now I'm gonna make a quick recap of the core fundamentals. First, because we're gonna work on the browser here, okay? We need to know how that thing works and how now the browser treat the HTML. So, because anytime you're gonna provide a style to one of these HTML tag, which is using CSS, in CSS everything has a box around it. So, understanding how this box works and how it behaves with other elements, a lot of time, this is the best way of how you can now create more complex user interface. So for that we need to take a look at what is this box things mean, what is the box anatomy, as well as what is the box properties, such as size and it is type, and inside of the size we have now intrinsic and restricted, and for the box type we have now is the how do you put it, what in the F is the type of blocks. So for example, or yeah, the types of boxes, whether it's block, inline, and anonymous. And that anonymous for us is something that is not quite relevant. Yeah, and box is something that is not quite relevant for us, okay? And I'm not going to go into the weeds with that. But with the type block and type inline, each one of them has a particular rules to follow, as well as some mathematics that you can apply to that. And they participate in something called now the box, or the block, or the inline formatting context. So this formatting context, the key feature of that is that not only allows us is to define or to make all of these elements inside of this formatting context isolated, so it's not all the elements won't affect that, as well as it is scalable because now we can define several formatting contexts, for example, not only block, inline, flex, and grid, which each one of them has certain rules which makes them predictable. So by knowing how this formatting context works, a lot of the time you will know how the things work and how you can actually build scalable web applications. And not only that, we need to know how those elements or how those blocks are put it on the browser or on the screen. So the browser have now this particularly position system, which is known as the normal flow, where it actually put all of these elements from right to left and top to bottom. And when you want to actually change the normal flow by using some of these position relative, absolute, or any CSS transformation that allow you to create now this layer out of the normal flow, or aka an stacking context, a lot of the time we can use that stacking context, or that set of or that layer that are or that layer that is out of the normal flow okay, as a way to now is create yeah as a way to now create is this isolation layer, or this stacking context, which is something that the browser used to create anytime you use one of these property, and also to perform some optimizations on those layers. So we can now make use of this GPU instead of the CPU. So the GPU is something that is used anytime you modify elements via JavaScript. So anytime you do that, or anytime you interact or you modify the elements on the DOM, now a reflow is triggered. Reflow is part of this stage at the assembly line of how the browser convert HTML, CSS, and JavaScript image and fonts into pixel on the screen. And with this particular process, or known as the critical rendering, which is, well, the browser now receives this from the network layer on your OS, and then translate that into, by creating an DOM and a CSS object model. And these two models, when they merge, create is a render tree that the browser know what are the elements that we're gonna live inside of this web application, but it doesn't know it is position or it is geometry. That's why we have now the reflow phase, where this reflow phase usually is triggered anytime you actually change the geometry or the position of one of these elements, usually via JavaScript. So the more you are interacting with these elements and trying and changing its positions and or alter its geometry, the more reflow you're gonna trigger. And if you have a lot of elements that are doing that, a lot of the time that actually make your application slower in those end device, especially in low power end device. So the TLDR of all of this is that we can now optimize that by using some of these particularly CSS properties like transform, where instead of actually having to modify is the layout phase, it goes now to the paint and compose phase. So this paint and compose phase, especially the compose phase, is now how the browser actually talk to the GPU. So by defining its set of layers, and initially is with the render objects, where each one of those elements on the DOMs has its corresponding representation of the elements, the DOM elements, right? What happened is that when we want, for example, create now render layers, or we tell the browser, hey, I want you to create a new stacking context by using is or the position absolute or relative, or changing the or using is a CSS transform, okay, or using is a video in canvas. So this is the way of how you can tell to the browser to tell the GPU, hey, we're gonna create this a render layer, a new render layer for you to be processed. And last but not least, when you need actually is directly GPU power, a lot of the time is via transform or 3D transformations. This is a way of how you can now interact with this GPU through the browsers by using this particularly CSS transformations or 3D perspective, right? Canvas and video actually make use of this graphic layer, which is the composite layers. So all of this is just as a way of how now the browser actually, this is now how the formatting context, how is connected to the stacking context, and how by creating this stacking context, a lot of time we can optimize is the reflow phase that it involves CPU, and we don't want to use CPU because if you have a lot of animation, you can block the render thread. So to prevent that, we prefer to tell the browser, hey, instead of using the GPU, please use the GPU instead of that. So uses this dedicated particularly hardware as a way to say, all right, now I want you to know when I use these particular properties, CSS transform or 3D perspective, I want you to now create is particularly layers that are more performance, or which is now talking directly to the GPU. So with all of that, all right, when we talk about the DOM API, okay, which is this interface that allows us to interact with this document, okay, because right now the DOM API, which is a set of methods that allows to interact with the document object model, most of the time, because we rely on on frameworks like React, Angular, or Vue, a lot of the time we delegate that to the framework. And if, as I mentioned before, if you want to build some low-level libraries like data management or state management or DOM management or virtualization, perhaps you need to build some components or more generic components. So for example, a video player or a chart engine or a single landing page with a minimal blueprint from one of these apps. A lot of the time it's important to understand how these things work, especially how the DOM works. So as I mentioned before, the DOM is this representation that is language agnostic. Any language, as long as they have this particular model where they can interact and parse an HTML, they can do that. In the context of JavaScript, we actually access directly through that via this DOM global objects that are exposed by default in the language. I am not a big fan of implicit stuff. Definitely I'm not. I'm more a big fan of explicit. Being explicit is way much meaningful, especially for junior developers for that, or senior as well. So this is the global object that we have. We have now the window that represents the screen. We also have the document, and inside of the document we have now is the body as well as the head. So how this DOM is organized, what is the structure of the DOM, right? What is the structure of this Megatron or this Optimus Prime? Well, you have now something called the HTML elements. where now it extends from something called element. We actually have a reference to the DOM API, and this elements class allows you to represent different types of not only HTML element but XML based syntax. For example, SVG, MathML, for example, right? And this element, which is a class from the abstract or from the base abstract class node called as the node, that actually has the property of the tree-like, the node, right? This node has something called, there is some class that extends from this node, which is the text node. It's a way to put some text representations on that, as well as the HTML document, which is something that is quite legacy here, something that I don't know why is this. But the thing is that exists, and this HTML document actually has a reference to the DOM API, where now this HTML document has this window. So this is now how this DOM is made of. Node, you have now elements that it can be HTML elements, SVG, blah blah blah, any XML syntax, and then you have is the HTML document, all right, followed by the text node as well. And when this HTML document it extends from the window. So why this is important, you might wonder, right? Well, because when we need to interact with this structure, okay, and you can think of this class hierarchy pretty much like when you have an oven. So what is the component of an oven or of a stove, right? You have all of these little knobs as well as the oven below, and each one of these knobs indicate is different part of your of that kitchen or of that stove. Hey, you can also graduate is the different temperature or heat intensity of each one of those how do you say, hornillas? I think it's a stove, exactly, of one of these stove, right? So yeah, this is one of the things that you can do for this is the operations that you can do. So pretty much in the DOM, these operations are querying, okay, adding elements, and remove elements, okay. So with the query, we have now 4 types of doing that. We got now the get element by ID, where this is pretty much like accessing like a key on a hash map, okay. The time complexity and read cost and memory cost are all 1, because now you have this particularly hash records of how you can access to each one of those elements, okay. But the situation changes when you need to use another way to query elements, which is get element by class name or tag name, right? So here we're using is the CSS selector as a way to actually is traverse through the entire tree collection by doing is the DFS. So when the browsers find that elements that match with these CSS selectors, it's going to return now something called as the HTML collection, which is a legacy return type, or is a legacy collection, which means is a live collection. What does it mean is that if someone actually modify or remove that particular element, you are going to see that reflected on that. So even though that the time complexity of this is linear time, in the first time when it finds all of these elements, because now the browser is smart enough to know that next subsequent query like that is gonna catch them. So the read cost as well as actually is on initially, and the memory cost here is low because we don't hold any copies, we don't create anything for that. We just only are traversing this tree structure, and not only that, we are going to get these live updates out of this. This has shown over the decade not a good strategy in terms of time, because anytime you need to, for example, if you modify any of these elements on live, what happened here is that it's going to essentially trigger a reflow phase, because after all this is a live collection. So anytime you modify, change the property, that makes a lot of sense. So anytime you change it is geometry or it is position of this element, the get element by class name or tag name, because this is a live collections. What happened is that when you want to modify one of them or see of a collection of them, you are now triggering is a reflow phase because this live situation. So I get it why this particularly query or particularly operation to query elements hasn't been. This is one of the disadvantage of this, and because of that, now we got is something called as the query selector. So this query selector, let me make a pause here. Okay. So these query selectors, right, is now an alternative, all right, to the get elements by class name, or get element by get element by class name. Okay, get element by class name or tag name. This query selector is an alternative where now things are quite different here. So the query selector and the query selector all, instead of actually returning is this thing called the HTML collection, which is a live collection, it returns now copy of this. Okay. Especially on the query selector all, because this element as well as the node list, because now this doesn't actually, the query selector doesn't actually involve is that's interesting. This is pretty fucked up, man. Oh, the matching is done using the depth first pre-order traversal. of the document node, starting with the first elements in the document markup and iterate through the sequential node by order of the number of child. If the specified selector match an ID that is incorrectly used more than once in the document, the first element with that ID is returned. So the thing here is that because this returns now is an element, an object representing the first element in the document that matches a specified set of CSX selector. If you need a list of matching that specify selectors, you should use query selector all like this, returning a static, not live, node list representing a list of document elements that matches a specified group of selector. That's what happened. And here, because it returns is an object, which is a copy of that. Alright, so the query selectors doesn't return is a live collection. In fact, its return is a copy of that. That's one of the things that is quite interesting here, because anytime you are now referencing object here, you are creating these new copies here. The way how the software actually works is that, hey, do you think that when you remove something, do you delete that? No, that's not how that works. In fact, what you're doing is that you're making all of those spaces available to put something there, right? So that's also a very philosophical question, is that how do you delete this? Yeah, but that thing still exists. No matter where you put it, that thing still exists. Even if you burn that out, that thing still exists over the air. You know, but how you can truly actually make something to delete, you know? What is the delete meaning for? Again, this is go beyond here. This is quite philosophical questions, but the idea here is to understand that where query selectors, a query selector is now this particular alternative that instead of returning is a live collections here, the query selectors now is going to return is the query selector is going to return is now this copy of this. The time complexity of this, it can be O1, because now it can be O1 or linear time. Initially it can be so it depends on the selector. So the more complex your selector is, the more time it'll take. Okay, and once it found that, so subsequent read to that actually make it constant time, so you can get that, as well as the memory cost here. Again, this is for query selector, but for query selector all, because you're going to return is now all of these collections, the memory cost is ON, as well as the read cost is O1, and this thing. So there is a couple interesting questions here, like why get element by tag name and get element by class name actually return this live collection? Because they want this to, and the years show that that particular approach of returning is this live collection has been something that has a lot of drawbacks. Especially because it triggered now this particular reflow phases, but and also is not that efficient in terms of read that element or to access that element, right? Where now with query selectors and with query selector alls, the alternative that now is going to return is an element or a node list okay, or a node list representing a list of the document elements that match the specific selector here. The TLDR of this, all right, or this performance overview is that when you're going to use this particular operation, okay, pretty much like if you have now a motorcycle or a bicycle, you know there's a couple things, even though an oven, there are a couple things that you should do as a way to use that in the most effective and useful way, right? One of them is don't put your hand on over the stove. No, it's not ideal. You can do that. I wouldn't recommend it. The other is that don't put too many heavy stuff on that oven, all right, on that stove, because it can break them, right? So all of these particularly things that are quite relevant as a way to understand how these things work and why these things works when it comes to this performance overview is that yes, get element by ID actually becomes an anti-pattern, because if you have to be careful about when to use that. The read cost and the time complexity is 01, all right. With get element by class name and tag name, it provides a low memory overheat, but because you don't need to clone the objects. In fact, actually is having a live collections to the elements, all right. And the other is a query selector, where even though that this performs slightly worse than get element by ID, due to the catching mechanisms, now you can do catching mechanism, you can now get some quite decent way of how you can read and access the data, right? So some of the best practice when it comes to querying your elements, all right, are like this. It's like, hey, simplify selectors, div, selection, flex, and largets. So simplify selectors, right? Especially if you're going to use that get element by class name or tag name, right? Simplify those selectors. The other is that use ID as the base containers, or use ID of core containers. So when you are going to iterate through all of these elements, if you know that particular elements or position or that particular container actually holds perhaps is an admin dashboard or a car component or that kind of thing, it makes more sense to actually use an ID, grab that element, and then work with that, right? So pick the right start point. So choose the most appropriate starting point for your queries. Starting from a closer ancestor to the desired elements can significantly improve query performance. Exactly. So the TLDR is that, well, use simple selectors and use ID of coarse containers, so you can now identify what is the right starting point to access to that, right? Can be silly, all right, but I get it, and I deeply get it. I deeply get it. Why is that? Because the whole point of this is to avoid reflow as much as possible. Especially if you need to actually operate to the elements over and over and over. Adding and removing elements, which is another operation that you can do. When we need to add elements or remove elements, all of them are horrible. So because inner HTML and insert adjacent actually parse the tree, or it needs to actually parse that content that you pass to them and then insert that, all right? With operations like append child or insert adjacent elements, it actually is less worse than doing the inner HTML, and this makes a lot of sense. This is something that you're gonna see a lot of time, especially if you're going to do some integrations, code integrations. Yeah, when you are going to do some, when you gotta do some code integration, that kind of thing. Um, yeah, basically, basically, when you're gonna do this kind of code integrations, yeah, pretty much, basically is that. Uh, you actually want to find what is the sweet spot as a way to actually get these elements, and then this third party widget, you want to insert that here as a way to actually make sense when this code is run. uh, Very, very interesting, by the way. Completely, man. Completely. And adding new elements, removing elements. Well, in the case of removing elements, is that as it is. So, let's go now to the down templating exercise, right? What in the F is this?
We're going to do some live coding, very simple exercise. So we have some HTML template that we need to utilize, and we have our create component function. So we need to implement the function that takes the title and the body, this is the string variables, and sets it to
Okay, so down templating exercise. It's like down templating exercise. There you go.
the h3 tag and card body content. There are multiple ways how can you implement this, but let's see what we can do here. And here we call this function, so this function should return HTML element, and then we append this element to the container. So to start with exercise, check out the repository. I hope you will have the link to the repository in the chat, or you can also click on the slides and open the folder begin and open the file index.html. We don't need any compiler or complex setup. It will be enough just to work with the HTML and use your favorite editor. And now I'm going to switch to the code. So I opened the index.html. So here we have our container, then we have our HTML, which is right now stored as a string, and also we have our HTML element, the function that creates our cart element. Right now it's empty, so our goal will be to implement this. So what can we do here? We could potentially just say, for instance, container, and then set the inner HTML. But then we would have to work with the HTML with the string directly, and representing the HTML as a string is not the best way to do things. So we want to have some kind of reusable way how can we represent the templates. So, and apparently in HTML we have this special tag called template. So we can remove this line, and in the head I'm going to use the template tag. So what this template does, it basically stores your HTML in the lightweight object in memory. So this content is not queryable by any DOM API. So any external scripts will not be able to access this content. So it's also not rendered on the final render tree. So if the user tries to traverse the DOM tree, they will not be able to see that this template is utilized. So it's kind of a lightweight representation of our card. So we added the card template into the template tag, and we also assigned the ID. So the content of the template is not queryable, but the template is. So we need to clone the content of the template. So let's update. Let's first query the template. So we can do document get element by ID, and then we use our card template. So now we have the reference to the card template. Let's clone the content. As we know, the templates use a fragment, so we need to clone the content of the fragment through the special method that I'm going to show now. So we're going to access the template, and the template has the property called content. So the content gives us the fragment that we need to work with. So then I'm going to use the clone node, and I'm providing the true flag to do the deep clone, and then I use the first element child that will return me the article. So by default, the first will return the fragment, but we need to access this element. This element is the element, and that's why we use the first element child. So now we have our article. We want to update the article content. So we need to set the card title and the card body content. So let's query that. So let's call it card title and card body, and then we use the document query select all, and then we're providing two selectors. The first one is the card title. Then we need to pass the card body content class. So now we selected two elements, card title and the card body, and now we want to update the text content of these elements. So we use the text content property and then assign title. Then we need to use card body and then assign text content to the body variable. Okay, now we return the card, and if we run this example, so now we're creating a new card element, and then we're returning this card element from the create card component function, assign some random text, and if you run the browser, we see that this doesn't work, and let's see why. And apparently, we're trying to set the text content so the property undefined.
Okay, but let's actually go to this one. Right. Link on the repo. You got it. Okay. Fundamentals of front-end system design. Okay, but you have several branches. Oh, I get it. Okay, let me actually clone this. There you got it. Alright. Let me actually put this inside of the front end code. Say front end master here. This is now make dir front end system design. Okay, system design that you got here is make dir front end, right? Front end. And let's go to clone this. And I want to now open this. And then open now with this. There you got it. I don't think you're gonna be able to see this. All right. Let me jump back to here. That's right. Right now you're not able to see what I'm doing, but you will, and there you got it. Okay. Awesome. Awesome. Fundamentals of front-end design. What is this? And I say, what is this? Would you like to update? Okay. And then you got it. This is the main. So git branch here, git branch minus a. Really? I don't believe it, man. Fundamentals. Really? What about here? If I want, okay, it's here that is now. Okay, cool, cool. So I want you now is to switch to that particular branch. Switch to, oh my god, I don't know, one. Oh, thanks, bro. But this is bash. Now this is shell. Exactly. And then you got it, right? It's like this one. This is a simple exercise. It's a way to do this. It's like, how can we actually put this, okay? How can we actually put this? All right. I want to also is create a new repo here. So GitHub. Yes, I want to create a new repo here. That's right. What? Okay. So now wait a single moment. Okay. Okay. All right. Now that we switch to done begin. All right. It is time for us to take a sip. Because that's what I want to take a sip. Good. Okay, here we go. So the whole point of this is to see how you can now actually do that. So implement the function. You can say, hey, just the title and the body. Okay, this is what we're gonna get from that. Especially as we call this, it's like front-end system design fundamental, and this is a random body text. Okay, so what we can do is to say, hey, put this on the inner HTML, but this inner HTML, as we can see here, right, has this particularly I would like to enable that. It's like okay, it's like nope. Tailwind fold, tailwind fold, toggle automatic class folding. Okay, option shift option A, shift option A. No, doesn't work. Shift option A. Shift option A. No. place or show. I think it's show. How can I hit this now? Carabiner. Exactly. Open up. Okay. What if I want is to show keyboard press macOS. I know that there is an application for that. ScreenFlow, no. Keys, that's one. Key, this one. There you go. All right. Good. Good. Good, good, good. All right. Awesome. Okay, is option. Okay. Okay. Oh my God. Okay. There you got it. Awesome. Awesome. So, all right. So that's exactly what I want to do. So as you can see, what I want is to pick that particular element. Okay. And insert is on the title, and then the car body, the body, right? So what I can do is to use some HTML extrapolation. Okay. All right. So identifies what is the car title as a way to work with that particular string, and then append that. But the more efficient solution for this scenario is to not only put this element here. Okay, not only put this element here. All right. Not only put this element here, right? But also is to use something called known as template or document fragment, right? This document fragment where this document fragment represents an object of the document, a minimal document who don't have any parent, and it is used as a lightweight version of the document that store a segment of the structure made of nodes. The key difference is to the fact that the document fragment isn't part of the active document tree structure. Changes made to the fragment don't affect to the document. So one way we can do is to say, hey, let's going to create now this document fragment. All right, where the return is a document fragment object. Okay, that unlike others, the performance benefit of document fragment is often overstated. In fact, in some engines, using document fragment is slower than appending to the document in a loop, as demonstrated in this benchmark. However, the difference between this example is so marginal that it's better to optimize for readability than performance. So I know that there is a HTML element called template. Okay. The content template, which was widely adopted and added quite a long time ago, by the way. Yeah, quite a long time ago. When you get is this. So, avoiding document fragment pitfall. When a document fragment value is passed, no append child and similar methods move only the child node of that value in the target node. Therefore, it is usually preferred to attach event handlers to the children of a document fragment rather than to the document fragment itself. Interesting. Exactly. I am in the DOM. I am the shadow DOM. And the shadow DOM with delegate focus. Okay. Let me actually take a look now at the virtualize, because the shadow DOM is a framework. Is a browser web technology for scoping variables and CSS in web components. Is for scoping the shadow DOM. It's a browser technology designed primarily for scoping variables and CSS in web components. Okay. But I don't want to dive too much into this. This is the global attributes here. HTML serves as a mechanism for holding HTML fragments, which can either be used later via JavaScript or generated immediately into Shadow DOM. It is a declarative version of the element.attach shadow method and accept the same enumerated values. Okay. So the template HTML, right? It's a way of how you can serve this. Okay. The template. So since this is the element content is not rendered, the corresponding HTML template elements interface include a standard content property with an equivalent content markup attribute. This content property is read-only and holds a document fragment that contains the DOM subtree represented by the template. This fragment can be cloned via clone node method and insert in the DOM. Be careful when using the content property because the returned document fragment can exhibit unexpected behavior. See avoiding document fragment pitfall. So this is it. The two main ways to use template elements. As part of the template document fragment or a declarative shadow DOM. Right now we're looking at the template document fragment and you are not able to see that because I'm reading here. But again, there is two main way of use template elements. Whether if you put that now as the template document fragment, okay. Okay, template document fragment by actually creating that, or declarative shadow DOM. If the template element contains the shadow root mode attribute with a value of either open or close, the HTML parser would immediately generate a shadow DOM. The HTML parser will immediately generate a shadow DOM. The element is replacing the DOM by its content wrapper in a shadow root, which is attached to the padding element. And this is the declarative equivalent of calling element.attachShadow to attach a shadow root to an element. If the element has any other values for shadow root mode or does not have the shadow root mode attributes, the parser generates an HTML template element. Similarly, if there are multiple declarative shadow roots, only the first one is replaced by shadow root. Subsequent instances are parsed as HTML template elements. But again, there are two ways of using now templates here. Whether it's template document fragment and the declarative shadow DOM. Again, remember that the shadow DOM is just a browser technology that allows to encapsulate, that allows to scope in CSS and variables. CSS and variables makes a lot of sense. CSS and variables. All right. Implementing a declarative shadow DOM. Avoiding document fragment pitfall. Similar to the slot, part of the Web Components technology suite. Web component, custom elements, shadow DOM, and HTML element, and HTML templates. Using custom elements, using shadow DOM, using template and slots. Using templates and slots, a guy showing how to define a reusable HTML structure using template and slot elements. Okay. I get into a rabbit hole here. I get into a rabbit hole here. Anyway, I get into a rabbit hole here. Nah. Exactly, and not rendering the DOM, but it still can be referenced using JavaScript. This won't appear in your page until you grab a reference to it with JavaScript and then append it to the DOM using something like the following. Although trivial, you can start see how this could be useful using template with web components. The key point of the note here is that if we append a clone to the template, content to the shadow root created using noCloneNode method, and because we appending its content to the shadow DOM, we can include some styling information inside of the template in a style, which this then encapsulated inside the custom element. This wouldn't work if we just append it to the standard DOM. Okay, adding flexibility with slot. A more involved example. That is not to be rendered when a page is loaded, but may subsequently be instantiated during runtime using JavaScript. And the other is that a placeholder inside of a web component that users can fill in with their own markup, with the effect of composing different DOM tree together. But the template is a client-side, is a mechanism for holding client-side content that is not to be rendered when a page is loaded, but may subsequently be instantiated during runtime using JavaScript. Holy moly! So, this is quite interesting. This is part of the web components, and I think that was a very interesting and particularly approach of that. Okay. As a way to put name on that. As a way to put a name on that. Okay. So that's why when we go back here to the code, here, and then we say, hey, instead of actually now exactly, hey, instead of actually doing this, right, which, and then append that to the inner HTML for that, which is, as we have saw, all of these particularly operations that we can do on in the DOM are not efficient. So that's why we say, hey, you know what, let's go to now use here something called as the append child, which is here, as a way to now improve that. But the question will be is that how can we now query this particular data and then access to the element, query these elements like so. Because now if we wrap this content as a template, which is used to declare a HTML element that can be cloned and inserted into the document by script. But the thing here is that this template are now client side, as is described here. So they are now client side code. What is it? It's a mechanism for holding client-side content that is not to be rendered when a page is loaded. So when you say to the browser, hey, I don't want you to actually render this content here, okay? I just want you to now hold that in memory. I don't want you to render that content here. I just want you to hold that in memory. So it can be instantiated during runtime using JavaScript. So when I now run this piece of code, which is now get element by that, you say, hey, that is you can say it's a template, right? It's a template. Where here we're gonna say, hey, I want to now access to the global object as a way to query these elements by ID, which is in our case, we're gonna call this is an article or car, right? Article or car.
Or in the Java container, the HTML direct with the strings, it basically
okay, car template, okay, and I want you to now get me this element. This get element by ID actually return me is an element, exactly an HTML element or an element, in this case an HTML element, right? And once I get that template, what I can do is to, well, append this content, okay, into one of these particular node, which means that, hey, since now I hold the reference here, I'm holding the reference, and what I want is to access to this car title and car body, but I want to now access to this small tree. What I can do here is get me now is the car title, okay, get me now the car title, because after all we want is to actually pass down that data, right, to the title here as well as the body. So this is a random body text, right? As well as the body content. So we can say, hey, this is the car title, okay?
Use the fragment. So we need the fragment deep the clone to do the deep clone, and then I use the first element child that will return. So the content for the special method that I'm going to show now. So we're gonna access the template, and the template has the property called content. So the content gives us the fragment that we need to work with. So then I'm going to use the clone node.
The fragment that we need to work with. Okay. Okay. So the template here is not what we expect that. It's inside of the content is that we get this information. Makes sense.
And I'm providing the true flag to deep the clone to do the deep clone, and then I use the first element child that will return me the article. So by default, the first will return the fragment, but we need to access this element. This element is the element, and that's why we use the first element child.
So what you're doing is that, hey, I want you to now clone this node.
So now,
interesting. So you are doing is now clone this down. You say, hey, since this now contains an HTML element, but template doesn't return that, so at least element is template. Template, what template returns? Okay. Okay, if the element has any other value for shadow ROM dude or does not have shadow root mode attribute, the parser generates an HTML template element. Okay. Exactly, part of the HTML and a specific one. An HTML parser can create either HTML template elements or a shadow root. And is here that is only read-only, the content, and read-only document fragment which contains DOM subtree representing the template element templates content. But this start from the this start from the so this start from here. HTML element content returns a template element's context, a document fragment. And then you say, hey, I want you to clone this, which means I want to clone node as true. Okay, which is now a property from the node, and then I want to get is the first element from clone node. In clone node, right? You say clone node methods. It must return is a node interface. Okay. May lead to duplicate elements ID in the document. If the original node has an ID attribute and the clone will be placed in the same document, then they should modify the clone's ID to be unique. So what is you doing here is that because this is going to return is a node interface. Okay, from the node, I want you to get me is the first child. Okay, because this return is now this node, which represents the elements on the tree. I want you to now give me the first element here. Oh my god. Which actually contain is
now we have our
the car. We say is first child. So the return value of the new clone So it returns a new node. First child. Is first child.
Article, we want to update the article content. So
exactly. So after we get the Jesus. So after because here the template because our because our content, because article content lies inside of our template, this is how we can grab that. Okay. Something that I'm not quite familiar, by the way. Not at all. Not at all. And that makes a lot of sense. Okay. Okay. Now makes a lot of sense. Okay. Which is now that we get that, the first child, and the first child actually is a node. If the node is a document, this property returns first node on its first child. The value is a node. Okay. So node here has several methods, by the way. So node here has several methods. Parent element here. Oh, but this is first child. Okay. Exactly, what we need is the element, my friend. First child element. We need is the element, not the node. Not the node property, man. Because it says the read-only first child property of the node interface returns a node first child in the tree, or null if the node has no children. If node is a document, this property returns the first node in the list of direct children. If you want to get the first element, exactly, that is child another element is considered, use the first child element here. First element child. This is if you want to get that. Exactly. Now first child to get all child nodes, including non-elements like a text or comment nodes. This is a way of how you can get is the element, bro. Exactly. To avoid the issue with no first returning text or comment nodes, element.first element childs can be used to return only the first element node. So we're using its first element child as a way to get me is the element that I want to work with. not the node. Things that the node exists, I don't care about the node property. I care about the element property. Makes sense? Jesus fucking Christ. Now that we get that, okay, what we can do is to look out for that, where now the element here contains actually is the property that we're looking for, which is find or query data. You know, get element by, in this case, we can say, hey, car get element, or in this case is a query selector, okay, as a way to now here you can pass several selectors. Okay, so query selector, so I want you to now is a query selector. Okay, if you need a list of elements matching the specified selector, you should use query selector. Like this, the selectors, a valid CSS selector, a valid CSS selector, which is, in our case, we want is to actually know pseudo class is my combinators and separators. Class selector, that's right. So class selectors, we can say something like this. Right? Yeah, class selector here, where we say now so I'm assuming that because of that we're gonna pass this a valid query selector. We have to pass this as a string and say, hey, get me is the car title here, followed by the car body, right? And query selector will return is an element, right? Or a list of elements. In this case, that's what I want. A node list, a node list.
We need to set the document. Then we need to.
Exactly, but here we're gonna get is the all of them as an array. Called title and car body.
Pass the card body content class. So now we selected.
Oh, and we can actually do this.
Two elements, card title and the card body.
Exactly. So because we are getting is a node list, okay. And here we want is, and here we make sure that we are actually getting is these two elements as a tuple. We got is the car, we got is the car title, no, a car title, and the car body elements. Okay, because now they are class elements here. Because they are now class elements here. Class selectors. Exacto, selector list. Separate by a comma. Okay, selector list. Where now query selector all is going to provide now a node list of elements. All right. It provides now this node representation of this. What we need to do is to, once I get that node, not the element,
and now we want to update the text content of these elements. So we use the text content property and then.
So the return is this, that a non-life node list containing one element object for each element that matches at least one of the. Okay, now this return is an element. Okay, so now this returns an element where we can say card title dot. Okay, this now returns an element where here we can say, hey, I want you to now from these elements not use inner HTML because otherwise it's going to parse that, but I want to now use is something called the text. Insert adjacent text, that might be one of them. Text content. Oh, but this is from the node. So this doesn't return. Okay. A non-life list containing one element for each element that match at least one specified selector or an empty node list in case of no match. Because this return is a node list, and this node list which contains now nodes, the property inside of that node is you can pass this now content to that. So this return now is a node, not an element. And then you say now, okay, text content, which is you are actually accessing to the node from the DOM. Holy hell. And then you say, hey, let's go to pass it the title. For the body,
then assign title. Then we need to use card body and then assign text text content
text
to
content
the body variable.
The body.
Okay, now we return the card, and if we run this, it's
and then after that you do that, you're going to return now the card. That is something expected for this component, okay, function that you're calling here, and then you assign that to a variable that is going to append that element as it is. So if we want to actually open up this, say, hey, open with reveal in Finder. And then I want to now actually is paste this thing here. As you can see, we're appending that element properly here. What? So we append that element property here once this script has run, you know. That's pretty fucked up. So after the script runs, the browser identifies this template, which is a document fragment of all of this, and then it mounts this with now the proper thing here. That's quite interesting. Silly, very silly, but there is a lot of machinery going on there. There is a lot of machinery going down there. Holy moly. Add a car using optimize add a car add car template using optimize query selector. To prevent reflow. That's pretty wild. No. Holy moly. Holy So that'll be all for this video. Oh my god, that's quite
Example.
interesting.
So the property. Okay, let's have the quick look of how could we potentially solve that. The first solution is HTML, but this is not the best way because we'll have to parse the content here in inner HTML. And if we want to repeat this operation, then it's not the most efficient way. So what we did is we just use the document fragment, which is the lightweight representation of HTML element. And since it's shielded from causing reflow, we can do whatever we want in memory. So it can also be reused many times, and it says isolated from the queries. And yeah, we utilize it to keep our markup component in HTML, which is a very natural place where we should keep such things. And then we just update our function and the solutions, and here is the final solution. Before we jump to the next section, do we have any question?
Can you just explain again briefly why doing it that way doesn't trigger reflow?
Yeah. So when you modify the fragment, it's not within the DOM tree. It's actually just in memory. So when you update any properties, so it doesn't trigger any reflow. So if you could potentially have the element in the DOM tree and you would need to, and you start updating the elements of the properties of this element, then this would cause reflow because the element already in the DOM tree. But since it's in memory, yeah, we can do any operations, and it's disconnected from the main DOM tree. The only thing that causes the reflow is when we use append child. So the DOM API is actually pretty simple. It has some limited set of methods that we can utilize, and it's very useful if we're trying to build some low-level things. But we need to think about the caveats that the DOM API has. So for instance, make sure that you utilize the HTML live collection wisely. So don't query too many elements, and then don't try to read the HTML live collection because it will result to quadratic time. For most of the cases, the query selector has a good performance, and you can just utilize it almost everywhere. So for rare cases, when you really need to have the live collection, make sure that you work with a small subset of data to reduce any performance impact.
All right. Okay. So
the next section is...
That'll be all for this video. Take care. Bye-bye. Yeah.